Okay, good afternoon everyone and welcome to today's webinar. We're very pleased to welcome Julia Clark of the IOSH Broadcasting and Telecommunications Group, who's delivering this session. Before I hand you over to her though, I just want to mention a few things. Firstly, for those of you who haven't attended one of our IOSH webinars, I'm Ben Pollard and I take care of the technical aspects of these sessions. Any problems and I shall try to assist as best as I can. On your screen then, most likely located at the top left-hand side, you'll notice a small bar with some written options on them. These are chat and Q&A. If you have any technical issues or audio problems and you need to message me at any point, please use the chat option. If you have any specific questions for Julia relating to the content of the session, please use the Q&A option. And you can ask your questions there. You can open and minimize these boxes at your own leisure. Should a message be sent out to you, it will flash orange. So with all that said, I shall now hand you over to Julia and I hope that you all enjoy the session.
I'd like to welcome you to this webinar today, and today this is really a part 2 webinar because we did the part 1 before on control of the electromagnetic fields at work regulations, and I was asked to do a bit more detail on EMF exposure assessment. So a bit of an introduction to me. My name's Julia. I work for a company called Link Microtech. Link are by far the most experienced UK EMF safety equipment supplier, and we're the agents for NADA, who are the world's largest supplier of EMF safety equipment. My background is broadcast engineer turned safety professional. Obviously, today we are trying to summarise what we normally deliver as a whole day course onto just a few slides. So this is very much to whet your appetite, and if you want to know more information about this topic, then do contact us about some of our longer courses. So what we covered previously then, this is just a reminder of what I covered in the first webinar, which I hope you've all seen. So I went through what the definition of EMF is, I went through intentional and unintentional sources, we talked about direct and indirect effects, articles of the EMF directive, the control of EMF at work regulations. I covered workers at particular risk, but I want to remind you again about that because that becomes very important when it comes to assessment. I also pointed you to how useful the EU practical guide is, and we had a very small amount on assessment and measurement. Today, I'm really going to focus though on assessment and measurement. So first of all, it's really important that you understand what we mean by workers at particular risk. So the directive says workers who have declared themselves to be pregnant, fitted with AIMD, etc. And we need to be clear that that obligation really starts for the employer once the worker has declared. So the worker has to say, yes, I'm pregnant, or, you know, I'm wearing a medical device, or whatever. It's really important that you know who your workers at particular risk are and where they're working so that you can take that into consideration when you do your assessment. For workers at particular risk, your starting point would be to assess against the much more conservative general public recommendations rather than the occupational action levels. So just a reminder then that Article 4 says we have to assess risks and determine exposure, and that requires employers to identify and assess all EMF sources in the workplace. And you can take advice from other sources. So information from the equipment manufacturers, published databases of generic assessments, things like that. But where it's necessary for an employer to determine the exposure, then that can be performed by measurement or calculation. Note that it's not sufficient just to demonstrate compliance with action levels or exposure limit values, as that might not be sufficient to protect workers at particular risk or to avoid risks from those indirect effects. Remember, I talked about electroexplosive devices and explosive atmospheres, things like that. So again, I'm going to point you to the incredibly useful EU practical guide, and in volume 1 it gives step-by-step guidance on how to do your assessment. So I've written the link there, and I think previously we sent a link out to the guide, and I think after this webinar we'll send those links out again, or we'll make them available on the IOSH website. So there's three volumes really. There's a volume 1, volume 2, and there's a guide for SMEs. If you're terrified, start with the guide for SMEs, because it clearly just lays out what you need to do, and it's not that thick, and you know, it's a good bit of bedtime reading. Volume 1 provides more detailed information, and Volume 2 lists a number of case studies, and it would be a good idea to check whether one of those case studies is relevant to your industry. If it is, then great, and have a good look at that. So, what do I do? Everybody says, Julia, what do I do? Right, take a deep breath and take it one step at a time. First of all, read section 1 of the EU Practical Guide. That's the volume 1. So just read that whole section. Identify who your workers at particular risk are, and where do they work in relation to your EMF sources. Identify all your EMF sources, even the trivial ones, and then look at the table 3.2, which is on page 24 onwards, to determine which of your sources need additional assessment for everyone or for specific workers at particular risk. In this way, you work your way through each EMF source using the table to determine if you need to do any further assessment. And it's an iterative process. Certainly when I've done this in organisations, you know, you go through it once and then you go through it again, and then you keep sort of peeling off and finding which bits you now need more information on. So I realise I'm referring to a document that probably some of you might not have looked at. So this is to give you a visual idea of what I'm talking about when I'm referring to this table 3.2. And it's easier to see how it works with an example in front of you. So if you see mobile phones use of, which is the third line down, and you look across the columns to see that assessment's not required for workers not at particular risk, or workers who are at particular risk, not including those with active implants, but assessment is required for those with active implants. And do you know, that's something as simple as don't put your mobile phone in your breast pocket, as that could interfere with the device. And to be honest, that's the sort of advice that person with that implant will have been given by their doctors anyway. And then if you look down again and maybe see the last two lines for base stations, this is mobile phone base stations. So you've got base stations inside operators designated exclusion zone and outside of designated exclusion zone. And something people worry about, but actually it says it's fine for everyone outside the exclusion zone. And in your workplace, if you've got mobile phones on your roof, mobile phone base station on your roof, if everybody's kept outside the exclusion zone, then great, no further assessment required. So there's some very simple quick wins using this table, and I really do heartily endorse that you should get to grips with that. So the bullet points here on the next slide then about the assessment process are taken again from the EU non-practical guide, non-binding guide for SMEs. And it's a really nice summary of what employers need to do. There's quite a lot of information available. If you've got newish kit, then ask the supplier. You know, I know in some experience we've had suppliers who pretend that they don't understand the question, but if your kit is relatively recent, ask the supplier and ask them, you know, tell me about the emissions of this kit for the operator in terms of the control of EMF at work regulations. It might be a bit of a problem though with older equipment, particularly equipment that might have been modified, or perhaps the supplier's no longer in business. And it might be more pragmatic to do measurements, which can be relatively straightforward with a survey meter like the ELT 400. So, you know, just go through this process and don't leap straight to measurement. Look at the information that might be available. So in the guidance, it says to assist with the risk assessment generally and specifically to assess compliance with action levels or exposure limit values, employers may need information on the level of EMF, and it might be available from databases or manufacturers or or it may be necessary to perform calculations or measurements. So all the guidance is clearly pointing you to looking for information first. And it's a very clear message to do a desktop assessment. Speak to that supplier and ask them, what level of EMF is the user exposed to. Also look at industry guidance. So the welding industry have the Welding Institute, there's Marston Towers Safety Group for broadcast and telecoms, and there's other trade bodies. So speak to your trade bodies. You're not, if you're part of a trade body, other people in your industry will be going through the same thing. Don't be working in isolation. But once all other options are exhausted, then you do need to move to calculation, modelling or measurement. So, although I've said you don't always need to perform measurements, but if you do, the process is often surprisingly simple. Modern measurement equipment is available, and it covers from static fields all the way through to microwave or millimetre wave frequencies. And the kit can often provide a result in terms of percentage of the action level, which makes it quite easy for comparison and assessment. Also, depending on the result of your assessment, personal monitors can also be a very useful additional measure. So in terms of quantifying the field levels then, when we're making measurements, all electromagnetic emissions have an electric and a magnetic component, and those values for the action levels are listed in both the EMF directive and the control of EMF at work regulations. And the electric field are specified in terms of volts per meter, the magnetic fields are specified in terms of Tesla or amps per meter, and power density is in terms of watts per meter squared, or sometimes you might see milliwatts per centimeter squared. And if you do, be careful about units there. But as I said before, some measurement equipment available now simplifies this by providing a result in percentage of the action level. So even if your measurement, though, doesn't read out in terms of percentage of the action level, if you've got single frequency fields, it's still a relatively easy process to identify the correct units of measurement and then do a comparison with the measured value and the action level. So just to remind you what the action levels look like, and I said previously that they are frequency dependent. And it's really important that you understand what you're comparing your measurement against. Health effects vary according to frequency, and so the permissible exposure levels also vary by frequency. This graph shows the action levels, low, high and lim, for the lower frequency range, and also see the lower line, which is the EU recommendation of 1999 for the general public. It's important to note that this is a log scale, so the difference between general public and occupational levels doesn't really show up, but that can be quite a big difference. So it is quite easy to exceed the general public levels for workers at particular risk. Similarly, for the higher frequencies, this shows the electric field action levels and how they vary with frequency. So a bit now about survey equipment. So what equipment should you use? Survey equipment provides a relatively accurate assessment of field strength and can be used to assess compliance against a particular standard as well, which I mentioned before. It does require a little training before it can be used, but in itself, it's generally pretty easy to use. It doesn't provide continuous monitoring, though, against sudden equipment failure or other changes in field strength. And this is quite an important point when you're talking about the relative benefits of survey equipment and personal monitors. Personal monitors are very useful in a situation where you can't rely on the fact that the field's not going to change, and they're very useful as protective measures, used very widely in the broadcast and telecoms industry. Then there's some frequency selective survey instruments, and really it's a mix of a handheld spectrum analyzer with an isotropic probe. It uses an active antenna, which is ideal for highly sensitive applications. more expensive than broadband survey equipment, but very good for what it's good for. A very good frequency range, and it can be used for very complex measurements, or it can be set up with very simple routines which can de-skill the measurement process. For safety applications, so it's relatively rare that you need an instrument capable of identifying specific frequencies and capable of going down to thousands or millionths of the action levels. But sometimes these are used where risk perception is important. So you might, for example, use it to demonstrate that for a general public example where perhaps you want to show that the telecom signals are very much lower than the other signals in the vicinity, like the broadcast TV or radio. Broadband survey equipment then are designed specifically for safety assessment. So you have isotropic probes, so they look all the way around, and they can provide average values as opposed to peak detectors. They're not frequency selective, and they'll attempt to sum all the signals across the frequency range of the probe. They're relatively insensitive, but capable of measuring down to low percentages of the action level. The good thing about this type of probe is that the equipment is designed to see EMF, as does the human body, so they're isotropic and average power detector, because those action levels are largely based on heating effect to the body. The probes sometimes look a bit odd, and we've had people say to us, "Oh, well, why is it on such a long stick?" And that's specifically to minimise reflections from the operator, so that it doesn't affect the measurements. It keeps the measuring end further away from the user. The thing that's important with this is the selection of the probe and making sure that the probe that you're using is capable of covering the action level and beyond. So the probes for these meters are usually electric field or magnetic field, but you do have some that have an E plus H capability over a relatively narrow frequency range, and that would be stuff like the NADA industrial meters, which are specifically designed for 27 megahertz heat sealers, and they measure both. Probes can be expensive, and generally the wider the frequency range, the higher the cost, but that defines the quality of the measurement as opposed to the meter. So all the smartness is actually in the probe. And these probes can provide either a flat or a shaped response. I'm not going to test you on this slide later. This is just to give you an example of the range of probes that are available, and you can see that each probe is defined whether it measures E field or H field and the frequency range that it covers. And of course, you would want to be sure that whatever it is you're trying to assess falls within the frequency range of the probe that you've selected. And but that just gives you a quick idea. I mentioned earlier about the difference between a flat response and a shaped response, and this is really showing you the difference. So a shaped response probe will know about the action levels within the control of EMF at work regulations, and it'll measure and give you the output in terms of percentage. So as I said before, it's weighted, and so instead of saying so many volts per meter or so many amps per meter, it'll say percentage of standard. So in this case, percentage of the action levels. And for a user, that's great, because less than 100%, game on, brilliant. More than 100%, oh, okay, I need to employ some control measures here. So you're just looking for, is it more or less than the action level? And it's really useful for multiple emitter environments. So where you've got lots of different frequencies, which might have different permissible exposure levels. So if the action levels are different for the different frequencies in use, it knows all of that and it works it out for you. So it saves you an awful lot of maths. So it makes it very easy to do comparison of measured values with the action levels. Here's an example of a low frequency survey meter, and this is doing magnetic field assessment. The important thing for these low frequency measurements is that the EMF directive references using what's called the weighted peak method. It sounds a bit complicated, but all it means is that for low frequencies, so for example 50 hertz equipment, it generates a lot of harmonics. So as well as the original 50 hertz, you'll have 100 hertz, 150 hertz, so it's, twice, 3, 4, 5, 6 times the original frequency. And what a weighted peak probe does is it measures all of that. It assesses the whole thing. So in this picture is a real world example of the harmonics generated by 50 hertz resistance welder. And this meter, the ELT400, is looking at the whole spectrum. It's weighting it, and it's coming up with a percentage of one of the action levels, either low action level, high action level, or limb action level. So I know that I often get questions about the weighted peak method, and it sounds a bit complicated, but really behind the scenes, the instrument is just weighting all of the peaks of the harmonic noise against the action level. Can you imagine how tedious that is to do manually? So you have to put a value against each peak, and then you have to weight that value against the action level, and then you have to add all those up. And the beauty here is that the instrument detects that, and it does it all for you automatically. So you just get a single total value in terms of percentage of the action level. So to summarize, with this kind of survey meter doing a weighted peak, there's a lot going on behind the scenes. You've got different waveforms, different harmonics, the action levels changing with frequency, but as I said, you don't have to worry about that. You get that single value in percentage of the action level. So it's quite an easy comparison and assessment. The ELT400, which is shown here, actually appears in the practical guide for this application, and it's tested and proven to work across a number of standards, both safety standards like the EMF directive and also EMC and product standards for stuff that's used by the general public, like white goods. So just a little bit now about static field measurements. Sometimes it is necessary to measure static magnetic fields, and applications like that might include MRI, maybe some rail and subway systems, and industrial processes that use very high levels of DC. Frequency range then for DC to 1 kilohertz. Measurement range would be 10 microtesla to 10 Tesla, and these measurements are quite easy operation by meter or by a laptop. When we do measurements, we need to think there's 2 basic measurement scenarios here. The first is intentional emitters, where you're absolutely intending to create that electromagnetic field because you're using it for something. So an example would be an antenna where you're actually deliberately creating a field. And for that, it's appropriate before you do a survey to perform pre-survey calculations. So you've got an idea about what you're expecting to see. With unintentional emitters, though, you can't do that. So an unintentional emitter might be a waveguide leak. It might be industrial equipment where the EMF is just a byproduct of the fact we're using a lot of electricity. And in those cases, it's quite difficult to calculate it field strengths, and sometimes impossible. But in either case, it's always important to gain as much information as possible before performing the measurements. So what sort of information do you want to get before you make measurements? What power level is the equipment? What frequency does it operate on? If it's an antenna-based system, is it possible to get information about the field strength for a given input power? Is the output intermittent, or is it on all the time? Do you need to measure both the electric field or the magnetic field, or both? And make sure you know what the action level is for the frequencies of interest. In terms of power level, I've just included this really to emphasize the importance of that basic sanity check. You know, if there's lots of power, you might get high fields, but if you're measuring a high field from a very low power device, then, you know, most likely something's gone wrong somewhere. So for measurements, the selection of the measurement instruments really depends on a number of factors, but the main points here are, you know, what's the frequency range that you require? What measurement range do you require? So, you know, do you need to measure very, very low levels, millionths of the action level, or are you looking to go from, say, 1 to 200% of the action level? And in many safety situations, that's more what you would be typically looking for. As I said, electric or magnetic fields or both. What's the overload limits? So it's very important that you are using your probe within its defined measurement range and also below its damage range. What you don't want to do is damage your equipment before you've even had a chance to make some measurements. And this last point's really important. So reputable equipment will have a detailed specification listing frequency sensitivity, isotropy, linearity, temperature response, calibration uncertainty, and it will be provided with a calibration certificate that's traceable back to national standards. If kit doesn't have a reasonable specification, at least including these points here, then don't buy it. If in any doubt, ask. There are no enforceable standards for EMF safety measurement equipment, and it really is a case of buyer beware. And if something looks too cheap and too good to be true, then it probably is. In terms of measurement techniques then, obviously begin the survey from beyond the calculated hazard distance. And if you don't know the calculated hazard distance, start from far away and move towards the equipment. At low frequency, so ELF to HF, then the measuring device should be mounted on a tripod, and that's to avoid body reflections. So you can put a probe on a tripod and have an optical link, and so that you can stand further away with your laptop or your meter to make the readings. Where possible, point the probe at the source of radiation, but as I say, try to keep your body and body reflections at a minimum. And for the same reason, hold the probe at arm's length away from your body. And always move slowly towards a suspected source. When you're making the measurements themselves, move the probe through an area with a slow and controlled up and down manner to find the maximum reading. Whenever you move a probe fast through an electromagnetic field, it tends to make the probes overread. So you know, make those measurements slowly and carefully. The minimum measurement distance between a radiating surface and the probe head is approximately 10 centimetres, and measurements inside that distance might be inaccurate. And also consider your uncertainty budget. Often that can be approximately plus or minus 50%. So think about that when you're interpreting your results. This last point about uncertainty budget is important. If you've got your measurement equipment from a reputable source, you'll be able to take readings at face value, and you don't need to worry too much about uncertainty because the manufacturer has in effect sorted it for you. But if you've purchased equipment with an inadequate specification, you'll have no idea of your uncertainty budget, and you could easily be out by a factor of 10 or more either way, which could make your measurements worthless. So, in terms of interpreting results, then take your worst case measurements and compare against the action level or the maximum permissible exposure level. Consider your measurement uncertainty, and if the value exceeds the action level, then consider whether spatial or time averaging is applicable. It's not necessary if your worst case measurement is below the action level, but sometimes it might be something that you might want to apply, particularly time averaging for a signal that isn't present all the time. You don't often need to get into it, but you know, we're happy to advise on that. So having done all these wonderful fine measurements, it would be a shame to keep them to yourself, wouldn't it? So obviously it's very important that you document your measurements in order to create a measurement report that you and your colleagues can then refer to later, and you can then refer to them in your risk assessments and when you're briefing your staff. And there's quite a lot of things that a measurement report should include, but here's a few examples. So specific location of the measurements. So one thing I always say is, could somebody else pick up your measurement report and repeat that? So anything that you need to put in terms of demonstrating what you did, where you measured, all that kind of thing. What kit did you use, so that somebody else can repeat it. So specific location of measurements, specification details for the type and the serial number of your measurement equipment, the calibration status of your measuring equipment, so what was calibration date, what the measurement uncertainty is, if and how calibration factors have been applied, obviously the results, and then the comparison with permissible exposure levels. It's worth saying here, and for the next couple of slides, that if you come across a measurement assessment report that includes all these points I'm talking about, then chances are it's from a reputable source and somebody who understands what they're doing. There's actually no regulation defining who's competent to do these EMF assessments, and with every profession there's good and bad, and you know, you need to, if you're thinking about employing a consultant, then it is a case of buyer beware. And really, that's another reason why we're encouraging you to do these measurements in-house. And if you're doing that and you're including all this detail, it will prove the validity of your work when other people are looking at it in future. So a full report should also include comments on any large discrepancy with any calculated values. If you've calculated values beforehand and you find there's a difference, well, why is that difference there? Values recorded in areas normally accessible by people. And you might at this point want to distinguish between where did the general public go and where is occupational only access. I think this is a really important point. We're doing assessment in terms of exposure to people. It's a safety standard about exposure to people. If you crawl behind a piece of kit with a probe and you manage to measure a really high level in a place where nobody ever goes when the machine is on, then it's a pointless measurement. So very important that we look at where are the people going to be when the field is present. So record information on any hotspots, make a note about any existing warning signs, engineering controls, or whatever, and what the temperature and weather was during the survey. You might also include information on emitter information, a map of the site or GPS coordinates, operational procedures to control exposure, permit to work arrangements, that kind of thing. So how effective those controls already are. An outline of hazardous areas. It's often very useful to have a plan so you can put red lines in and actually draw in the levels, the areas where the levels exceed the action level. And the existence of any other hazards, so fuel, combustible materials, whatever. And perhaps the attitude of workers to EMF hazards. So, as a summary, I know I've said a lot of stuff, but we're into the summary slide now. Check that the equipment that you're using is appropriate for the use. So is it E field? Is it H field? What frequency range is it? What measurement range is it? What's the overload level? What's the damage level? Does it do that weighted peak measurement that you would really want to do at lower frequencies? Check that the equipment is functioning correctly. Preferably with an RF source. So once you've turned it on and it's booted itself up, just use something like a walkie-talkie just to check that the equipment is working properly. Check the calibration status, and if you need to use calibration factors, check that you have the right ones for that specific piece of equipment. Decide beforehand on the units of measurement that you'll be using. Are you using volts per meter? Are you using watts per meter squared? Are you using percentage of action level? And make sure that you check that you understand what the action level or the limit that you are measuring it against. So be clear that, you know, particularly where you're not measuring in terms of percentage of standards, but if you're reading in terms of volts per meter or Tesla, you know, what limit am I measuring against? So that because when you get close to the limit, you'll be wanting to make more measurements. If possible, beforehand, calculate hazard distance if you can. Take measurements in a slow and controlled manner. And if you get any anomalies or things that don't quite seem right, then make sure that, you know, just recheck anything that doesn't seem right. So, and in terms of reports then, in any written report, make sure you include the equipment details. So the manufacturer, the model number, serial number, calibration dates, whether or not calibration correction factors have been applied, and estimate of measurement uncertainty. So when performing measurements, don't put yourself at risk of overexposure. I can't stress that enough. You know, always start your measurement from way outside the hazardous areas and walk slowly towards the source. Remember that the lowest maximum permissible exposure levels are in that VHF range, the 10 to 400 megahertz, because of the whole body heating. So make sure that before you make your measurements, you know what's the limit of where I personally am going to stand while I'm making this. I have in the past seen people, you know, walk into an area where it's many times more than the action level, and I've sort of said, hang on a minute, come back, you know, approach your source carefully. Minimize the time in potentially hazardous areas, and maximize the distance between yourself and the sources. It's very important to understand that power levels do fall off very rapidly with distance from the source. So you know, a small amount of distance can make a lot of difference. And as you are closing that 100% of the action level, that would be an area where you're starting to make a lot more measurements. But always keep yourself safe. Assume all sources are active, and be aware of any warning notices or exclusion zones. So I know I've galloped through quite a lot of information there, but important to remember that EMF safety issues are usually relatively easy to resolve. And rather than getting a consultant in for a one-off job, you know, it is so much better for organisations to take that ownership in-house. And at Link Microtech, we're really happy to help you with that process, you know, in terms of advising about which test equipment is appropriate, through to providing either places on our general training courses or providing bespoke training for you and your organisation. If you're still not sure where to start, then the guide for the SMEs is a really excellent place to start. You know, it gives you a good introduction, and then go on to reading volume 1 of the guide. But if you need to make measurements, you know, most measurements, as we said, are easy to perform. Remember that basic risk assessment, you know, that sanity check, you know, is the equipment high in power? How close to people do you have to get to the source? And how long do people need to be there? And always remember to consider workers at particular risks. So galloped through the slides there a bit, but we still have a little bit of time, I think, for questions. So I think we've had 1 or 2 come in. So the first one I have in front of me here is when where do you do your full day measurement course? Well, we did one last week actually in our office in Basingstoke, and we schedule them fairly regularly. So if you are interested in coming on one of our measurement courses, do drop me an email and we'll put you on the waiting list, and we'll let you know as soon as we've got the next course available. We do also take our training into organisations. So if you have a number of people who need some training, then sometimes it's more cost effective for us to come to you. So we've got one or two questions in here. So there's one, why 10 centimetres for minimum distance to measurement between the radiating surface and the probe? It's a bit of a rule of thumb. So, you know, it does depend very much on the frequency and the probe and everything else. So that 10 centimetres is a rule of thumb, and it will vary with frequency and with the size of the probe. So you know, but just understand that there is minimum measurement distance, and you need to be aware of it. Certainly placing probes right against sources is not good practice. So next one. Right, my employees are an offshore marine contractor. We've been advised that marine high voltage equipment is exempt from the regs. However, is non-marine high voltage services used for offshore remotely operated vehicles exempt from the EMF regulations? Right, it's an important point when we talk about these exemptions, that the exemptions are not a complete get out of jail free card. The exemptions are exemptions from the exposure limit values, but only in the situation where the employer is demonstrating that they are using an alternative framework that still provides safety for their staff. So a good example for that would be perhaps the military exemption, where they are exempted from the action levels in the control of EMF at work regulations, but they're expected to use an equivalent standard. So, for example, one of the NATO standards. So it's not that it's exempt and you still have to demonstrate. You have responsibilities under the Health and Safety at Work Act to provide a safe place of work, and you have the responsibilities under the management regs to risk assess and put in control measures where the levels are not safe. So it's not as straightforward as that. Next question. Right, as most equipment these days is manufactured in China, is there a standard or recognised body marking that one should look for when looking at measurement equipment? Well, I think the slide that I put up before, which told you to look at some of the specifics around, you know, what the, if I can find the, let me just find the slide. I'll just, ooh. Typical now, I can't find the right slide. No, I can't find it. But basically, you know, there was the list of equipment that you know says you should be looking at. You should be looking at what's the uncertainty, what all the equipment specification is, and the calibration. So make sure it comes with good calibration. So there's another one here, sorry. We are an oil company. We are NMR laboratory. What measurement device do you recommend? I don't know what you mean by NMR. Okay, I'm going to have to take that one offline. If that's from Salim, if you want to email me the question, Salim, I'll get one of our test equipment specialists to come back to you on that one. So, right, so the one says, right, you said that meters give the average level, not the peak level. Does this mean it averages over 6 minutes? No. Sorry, yes. 6 minute averaging is a different thing. When I said average, what I mean is RMS. So root mean square. So not the peak reading, if you like. So it's averaged over a cycle, and that's quite important because it's the RMS value, the root mean square value, that affects that is more related to the heating effect. So so no, I didn't mean specifically 6 minute averaging on that. Okay. So next one, related to weighted peak measurement. Would equipment with the following specifications be an example of when this is required? I can't read it. So power 100 to 200 to 240 volts, 7.1 amps, 50 to 60 hertz, where EMF is byproduct. Well, you've only got 7.1 amps there, and when you look in the guidance, it refers to assessment being required for equipment over 100 amps. So it might be that for that it wouldn't be required at all. But all of the questions that we're being asked today, I will take back to our measurement specialists at Link Microtech to make sure that we've given full and accurate answers. So another one here. Do you know some EMF database? Well, I do know that the welding industry have done quite a lot of work on creating databases of emissions from particular equipment and use situations. So that would be quite a good example. But I think it depends what industry that you're looking at, really. So I think it's very important that you know, people ask their trade bodies if they've done any work on this. It's a real pain to have to reinvent the wheel. So, any more questions?
So what we're going to do, I'm just going to, whilst we wait for some more questions to come through, I'm just going to quickly launch a poll for everyone. Just if you wouldn't mind taking sort of 20-30 seconds or so just to quickly whiz through those and answer those for us, that would be great. We do appreciate feedback, obviously. And whilst we're waiting on that, we'll just see whether any more questions come through, and we will answer those shortly.
Okay, just had another last minute question come in. Would I be correct in understanding that if a piece of equipment, e.g. ground surveillance radar systems operating on 77 gigahertz frequency, is compliant with EU regs for permissible RF exposure levels to the public and falls within those levels, i.e. PFD limit of 10 watts per meter squared, that a specific measurement and assessment does not need to be carried out? Well, I think you mean the EU recommendation for general public, because it's the EU, that there isn't EU regulation about general public, it's an EU recommendation of 1999. But yes, if something meets the EU recommendation for general public, then normally it's fine for occupational. You might still need to do some assessment in terms of other safety effects like explosive risk and things like that, but otherwise yeah, it normally, if something is if you have data to say that it's compliant with general public recommendations, then that's great, and you put that in your risk assessment and job done. And there's another question about, apologies if it got mentioned, but we'll be able to access a copy of the presentation for our own reference, please. Yes, the last one we did was put up on YouTube, and there was a link from the IOSH page about the event. So yes, we'll make sure. I don't know how long that will take, but I'm sure Ben can answer that, and IOSH will be putting it up. If there's any further questions, either from the questions or further points we want to make on the questions that were asked already, or if anybody's got any further questions after the event, after they've had a chance to digest it a bit, then do either drop me an email or drop the IOSH team an email, and we'll get those answers. So we may put up a further list of questions and answers.
Okay, great. Yep. Just to reiterate what Julia was saying, yes, certainly this will be put on the group's microsite. I'll be emailing all of you either later today or early next week to provide you with a copy of the presentation and also the recording of today. If you do have any further questions, as Julia said, you can email her or you can get in touch with us, and we'll pass it on. All that's really left to say now is thank you very much to Julia for attending and for delivering a session. I hope you all found it really useful. Just flicking through some of the feedback, it looks like everyone certainly found it very, very informative, which is fantastic. So all that's left to say now is thank you very much for coming, and hopefully we'll see you next time, and goodbye.